皆様、こんにちは。ブラバンのテルブル大学ので教授を務めております。Henk Akkermansと申します。本日はこのような素晴らしい機会をいただき、皆様の前でお話しできることを大変光栄に思っております。どうぞよろしくお願いします。So, my talk is about a challenge common to many industries, from infrastructure and energy to telecom, high-tech manufacturing. It affects Japanese and Dutch companies alike. It concerns the challenge of engineering both reliability and scale, both quality and quantity. And in the beginning of the life cycle, and that's where we are with photonics, these are both low. How do you get them up quickly? Now, the challenge here is how to move from problems that you discover downstream and learn from them and bring that knowledge back upstream to improve the early stages. I will focus on high-tech electronics, such as photonics, of course, but I will also draw on examples from my own research of 3 decades across different industries. So the previous speaker already indicated the V of system engineering, an important concept. Because in supply chains, often problems become visible only in the downstream stages, whereas the causes lie upstream. And the idea of system engineering is to anticipate the entire life cycle already during design. Unfortunately, though, in practice, that's impossible. There are always unknowns. Moreover, in practice, unfortunately, later stages, such as operations and maintenance, often receive less attention than development and production that come first. The key question is, therefore, how can we systematically feed downstream learning back into production if we cannot design perfect products and processes from the start? Now, I will discuss this in 3 parts of the supply chain over its life cycle, and I will start in the middle with manufacturing. So in the 1990s, I studied Compaq in Houston, then one of the world's largest electronics computer manufacturers. And that learned me a lot about ramping up the manufacturing stage of the supply chain, or how not to do it. The company struggled to ramp up laptop production back then, because quality problems generated large amounts of rework. Failed products accumulated in a large storage area they called the pit, but management focused on production output, on scale, rather than understanding from those failed products in the pit the causes of failures and feeding that information back upstream. As a result, little knowledge and no reliability improvement was generated, cost increased, and the production ramp-up failed. Now, this lesson is familiar from Toyota's Kaizen philosophy. Continuous improvement requires learning from small failures quickly and systematically throughout production. Later, at the Dutch aerospace company Fokker, I observed a solution from the engineering stage of the supply chain that comes before manufacturing, where most of our discussions are about today. There, back then, detailed engineering started before often before basic engineering was completed. Now, by definition, that creates rework, but it also reveals upstream design problems earlier when you find them downstream. Because waiting for perfect information, that sounds attractive, but perfection never arrives. Unknown issues are discovered only when downstream teams work out the details. This approach is now known as concurrent engineering, and it proved more effective than the strictly sequential development in many engineering projects back then in aerospace and beyond. Now, a similar evolution occurred in operations and maintenance, the stage that comes after manufacturing the supply chain. This is a stage where you get customer interaction, crucial for scaling up. As this slide shows, back in the 1950s, we had corrective maintenance, repair after failure. Then came periodic maintenance, servicing equipment at fixed intervals. Today, many companies use risk-based maintenance, focusing resources on the most critical assets. But all these approaches do not leverage the value of downstream digital data. The next step is condition-based maintenance, using sensor and operational data to determine for a specific asset when that specific asset really actually needs intervention. Now, the technology is available, but implementation requires sharing data across organizations. Many OEMs face a bootstrap problem. They need operational failure data to develop predictive models to offer condition-based maintenance as a smart service to their customers, but their customers are reluctant to share this data before the algorithm works, before the benefits are proven. And that's a bootstrap problem. So, we see solutions all around the supply chain, but in practice, they're not happening enough yet. Now, what are the root cause complications? I mentioned 3. First of all, long asset lifetimes. Although it now sounds silly to think about that, remember that most ASML systems produced since the 1990s, and even some of those from the 1980s, are still operating today. How about many other sectors? Rolling stocks of trains, machines in general, and so on. And over such long periods, multiple generations of stakeholders become involved. And preserving and transferring knowledge across these generations becomes a major challenge because all the design teams have long gone. A second challenge is that information naturally flows downstream through the asset lifecycle. Products, services, documentation, they all move forward. But learning and data do not naturally flow back upstream. And yet, effective improvement depends precisely on creating those upstream feedback loops. This leads me to a third challenge. This comes from the evolving nature of software-intensive systems, such as also, for instance, telecom service and digital television, in which I also did research. In digital services, just as in modern high-tech equipment, or your electrical car for that matter, changes occur continuously. There are upgrades all the time. And those software upgrades, yes, they can improve performance, but they will also create new performance problems. And as a result, the feedback from operation to design, that's no longer a one-time effort. It has become a permanent process across the life cycle. So, what are the solutions? Again, 3. First of all, create those feedback loops. Now, this slide may look complicated, perhaps it is, but the solution is conceptually quite simple. Organizations must create business and IT processes. Yes, we'll talk a lot about technology today, but business and IT processes that systematically capture downstream information and feed it back upstream whenever and wherever that information becomes available. Now, the difficulty isn't in the understanding of the principle, the difficulty is in organizing it across multiple independent companies and business functions. And that brings me then to the second solution. This requires sharing data and knowledge across the supply chain. The OEM, the asset owner, the service provider, key suppliers, they all possess part of the knowledge needed for improvement. But perhaps a new coordinating role is required, an independent service control tower that helps combine data from across the supply chain ecosystem and share it back. For such sharing to succeed, every participant must benefit. But sometimes, or I would almost say often, those benefits arrive sometime after the costs are made. And those costs are made by another participant than the one that gets the benefits. Now, this means that contracts and governance structures must be redesigned accordingly, different from those of today. This brings me to my conclusion. The fundamental challenge is to stop viewing supply chain relationships as purely transactional, as zero-sum games with winners and losers. There's too much of that thinking in the world anyway, I would like to add. Instead, we should view engineering reliability and scale as collaborative process innovation. And please forgive me for suggesting to compare this to how a Japanese Renga is being made. Many contributors there build on each other's work to create something better than any individual could create alone. Now, the Netherlands and Japan have worked together in science and business for more than 425 years. I believe collaborative process innovation offers an excellent opportunity to continue that tradition. ご清聴ありがとうございました。